All right, so in 1-3 we talked about graphs of functions, okay? This time I gave you the graph and you're answering the questions based on the graph. Test-wise, you'll be coming up with your own graph and then answering questions. So I'll give you the equation. You'll have to use your graphing calculator to graph it. You'll then draw it like to the best of your ability so that I can figure out if you get something wrong. Was it based on reading your graph wrong or if you actually graphed the graph wrong, okay? But then you're going to have to answer the questions based on it. So for the first one, it says find f of 1. Remember, this is where we're looking for where my x is 1, and I want to give the corresponding y. So x is 1 here, which means the corresponding y is what? 2. Okay, f of 2, I go to where the x is 2, find the corresponding y, which is 4. Questions on either of those? So this might take tracing on your calculator too. So realize that maybe it's not going to be as easy to see. Make sure you know how to do the trace. Make sure you find your max and min, your intercepts, all that stuff from your graphing calculator. Number 3 says find domain and range. So because this is cut off, these are implied to be arrows, which means my domain, which is the left to right, would be what? Negative to positive. And then the range, which is bottom to top, negative infinity to positive infinity. So there's no restrictions here because the arrows point in all directions. Okay? Number 4 says find the values of x for which f of x equals 0. So f of x is the same thing as what? Y. So it's saying give me the values of x for which y is 0. Okay? Where is y 0? Here and here, the x-axis, right? Which in this case would be 0 and 3. It says find the values of x. So I'm not writing these in coordinate point form. I'm literally listing these. Remember that you can call these more than one, right? We said these are x-intercepts. What else are they called? Roots, zeros, solutions, right? Those are all the same thing. Number 5 says state which intervals the graph is increasing or decreasing. So as I move from left to right, the first range is this, which is in which direction? Decreasing. And I would give that interval how? Good. It's my x, so negative infinity to 0. And then it changes direction. It goes up or increasing. Which is what to what? 0 to 2. Good. And then it changes direction again. And it's decreasing again, this time from 2 to positive infinity. Lillian? You can put the u in there. Like, I'm not going to mark it wrong if you don't give it to me, but you can put the u in there because it's both of those. You're welcome. All right, 6 says state all relative max or min values. So now we're looking for everywhere the graph changes from decreasing to increasing or increasing to decreasing, and it's happening twice. These are points, so I give it to them at 0, 0, and 2, 4. You want to write those in point form. Questions on any of the warm-up? Okay. So 1, 4, we've been talking about getting to this point for a little while. It's all about transformation. So I'm going to give you an equation. You're going to identify the parent function, and then you're going to shift it. Left, right, up, down, vertically stretch or shrink, reflect, all those kind of things, okay? So we start with just what are some basic graphs. The constant function is your horizontal line, okay? And then for each of these graphs, you should be able to identify, we're not going to do them every time, but you should be able to identify domain and range. You should be able to identify if it's even or odd or symmetry, any of those things. So for the constant function, which would be like a y equals a number, it would be a horizontal line that runs straight through that number. Domain is all real numbers. The range is whatever number that is. So this looks like it could be like around a 1.5 kind of a thing. And then increasing and decreasing behavior, this thing is constant the entire time. And then you get to an identity function or a y equals x, because that's the same thing. This would have an intercept at 0, 0. My slope is 1. Domain is all real numbers. Range is all real numbers. And it's increasing on the entire graph. Then we get to absolute values, square root, quadratic, and cubic. So these all have arrows at the end. An absolute value is a v. So it has a sharp change of directions. Square root function, starts at 0, 0 and points up to the right. Quadratic is similar to the absolute value, except that it is more rounded near the 0, 0. And your cubic function is like a parabola in which one half of it is flipped facing the other way. So if I asked you for domain of absolute value, you'd tell me it's what? Negative infinity to positive infinity. There's no restriction on absolute value, right? You can plug any number in there. Same goes for quadratic, right? I can plug any number in there. I'm going all the way left to all the way right. How about square root function? Is there a restriction this time? Yeah, right? What is it? Has to be positive, so we're saying from 0 to positive infinity. And then the cubic function, back to no restriction, my arrows point all the way left and all the way right. If I go back and fill in range for each of these, what's the range on absolute value? What's the lowest y? 0. What's the highest y? Same thing for my quadratic. Same thing for my square root. Cubic function is the only one that's different. This one has negative infinity to positive infinity because the arrow points down and up. How about even and odd? Are any of them even? How do I know they're even from the graph? Symmetric over the y. So are any of these symmetric over the y? Which ones? Absolute value. This is even. Square one is also even. How do you know if something's odd? The origin, right? So either the y equals x or the y equals negative x line, or flip it down and over, or any of them like that. The cubic function is odd. And then your square root would be neither. We won't go individually through them, but I would make sure I would know how to do increasing and decreasing behavior for all of them too, okay? Okay, little less common, but you'll still see them are the cube root function and the reciprocal function. So the cube root is almost like your cubic function, but it's turned sideways. Or if you think about the square root function, it's reflected over the origin, okay? Domain here is negative infinity to positive infinity. Arrows point left and right, and you can cube root anything. Range, negative infinity to positive infinity, and it's constantly increasing. So it's increasing from negative infinity to positive infinity. The reciprocal function is 1 over x. So now I've got a restriction on domain because I've got a variable in the denominator. So the parent function, it can't equal 0. There's a asymptote here and here, if you remember from your rational functions in Algebra 2. Which means my domain starts and stops. It says from negative infinity up to 0, and then 0 to positive infinity, but it can't include 0. And the same thing for the range. And it's decreasing, so if I move from left to right, this whole section here is decreasing. It stops, and then it decreases again on the other side. And this one's an odd function, so is this. All right, so now we start to move them. So the first shift is a vertical shift. If you add or subtract after the function, so after the absolute value, after the root, after the square, after the cube, if you add, then you're shifting up that many places. If you subtract, you're shifting down that many places. If it's a cube root, it would be like this. And if it was a reciprocal function, It'd be like this. Even a line would happen, right? Like if I had y equals, well, it wouldn't be y equals f of x. Plus a number is going to shift up. Minus a number is going to shift it down. All right, so let's baby step our way in. First thing you want to do is identify your parent function. What's the parent function of a? X squared. What does that look like? A parabola, right? And if it's plus 1, what is happening? I'm shifting up 1. So the only exact point you need is that vertex. The rest of it can be an approximation. If you wanted to plot points, you could plug in a point to the left and the right of that vertex. But for right now, we're just finding an approximation. How about B? What's happening this time? Shift down 2 places. The next shift is horizontal. So this happens if it's inside the function. So if it's x plus inside the absolute value, or x minus inside the absolute value, if the plus the number or minus the number's underneath the root inside the parentheses, or if it was cubic underneath the cubic function. Or if it's a reciprocal function, it would be in the denominator with it. So what's weird about the horizontal shift is that if you think plus and you think left and right, you would think right, and if you think minus, you would think left, but that's the opposite of the case, right? If there's a plus inside the bars or underneath the root, then you're actually moving in the other direction. You're going left. And if there's a minus, you're going right. And if you think about why this happens, like this is based on, if I was trying to find the x-intercept of, let's say this, right? If I'm trying to find the x-intercept and I would change it so that it would be plus and minus 0, but it still stays 0, and I go to solve, what happens to that 1? It becomes a negative 1, right? So if you're solving what's inside the parentheses, it actually changes the sign on that horizontal shift, which is why it's obviously the opposite sign, okay? So looking at A, what's my parent function? It's a parabola again, right? What's the minus 2 inside the parentheses? Right 2 places. And B, the plus 2 inside the parentheses doing what? Left 2, and the negative 3 is? Down 3, right? So I go right, or I go left 2, down 3, or you can go down 3, left 2, doesn't matter, as long as you plot that point, and then my parabola. So obviously you can have more than one shift at a time. You're not going to get a question on a test from me with one shift. Everybody still good? Mm-hmm. Still easy stuff, right? How many of you remember this from last year? Good. All right, then we get the reflection, and there's 2 types of reflection. If the negative is in front of the root, or in front of the absolute value, or in front of the x on the cubic or the squared, then it flips it across the x-axis. So this is flipping this upside down. So this would be a parabola that faces down, a V that faces down, an upside down cubic function, and a square root that points down. And then the negative under the root flips it across the y-axis. So now this one is pointing left. I shouldn't do that arrow. Without a horizontal shift, the square root is really, well, I guess I should say the cubic root too, is really the only one that really matters if you flip it. So if I were to do, let's see, cube root with a negative, it's turning it so that normally it goes like this, but instead it goes like this. Other way around. Like that. So it flips it over, which is going to be the same as if it's flipped upside down. So those two look the same, whether the negative's on the front or the negative's on the inside, because whether it's a cube root of a negative number or the negative cube root of a number, it's going to be the same. Okay, so those are going to be the same. When this really gets confusing and when it starts to be a little bit trickier is if you've got a negative on the inside of a parabola or an absolute value, right? So if that negative was by itself, the negative absolute value is not going to matter, right? Like if I don't shift it right or left and I flip it over the y-axis, it's no different, right? Like a v looks the same whether you flip it horizontally or you don't. Does that make sense? But as soon as you add on a shift, it's going to take on a new change. So if I add a shift, there's two ways to look at it. One is plotted as originally is, so I'm going to ignore this first. I'm going to do this one first. So if that was a +3, which way would I normally shift my absolute value? To the left 3. So I'd go 1, 2, 3. I'd plot my v like this, okay? But then this negative says flip that over the y-axis. So 1, 2, 3, flip it over the y-axis, and it actually is here. And that would be my answer. That's one way to look at it. The other way is if I actually took and solved what's inside this absolute value. Normally it would be -3, but then there's a negative there, which means I would change it to a +3, okay? And so if that's the case, then you can ignore the flip over the y and just move in the opposite direction. So your options are to graph it with this first and then flip it over the y, or instead of it being a +3, which means move left, you move right. So I would just move to the right 3 places and draw my absolute value. So the same thing's going to happen with a parabola. If it was this, I'd move it 3 places to the right. If it was this, I'd move it where? 3 places to the left. Does that make sense? So you either move it 3 places left, right, and then flip it over the y-axis, or you just move it 3 places left.
What happens if it has negative before the square root?
Before the square root?
Like, yeah.
Or here, before here.
Yeah.
So now it's upside down and on the other side. So good question. If it's this, right? This causes that to become the other direction. So normally a minus goes right, but instead it's going to go left. 1, 2, 3. It would be here. And then this causes it to go upside down. So you've got both reflection over the x and over the y. All right, you try them. So figure out what your parent function is, identify the shift, and then graph it. All right, so what's my parent function? Square root, which is that little like half the parabola turned sideways, right? Okay. What's the negative on the front telling you to do? It's going to point down or be upside down, right? Yeah, point down's fine. As long as you know what you mean, I'm good with it. And the +1 underneath does what? Left 1. Okay, so I'm going left 1, and I'm pointing my little arm down. Let's say you couldn't remember the difference between the negative on the outside and the negative underneath. What could you do to see if you're right? What do you do with a graph if you have no idea what it looks like? Plug in a point. Figure it out, right? If you don't know if that's supposed to point left or it's supposed to point right, and you go plug in 0, and you get -1, there's your confirmation that it was supposed to point down. Okay? So these are easy to check. B, what's the negative underneath doing? Over the y, right? Or pointing left. Left. Over the y, however you want to word that. The +3 is doing what? Up 3. So I go up 3, and I point it left. This time if I went to check and I plugged in like 1, I get the square root of -1, which doesn't work. That's how you'd know there'd be no points on the right-hand side. Okay, so the last kind of shifts are non-grid transformations. You're not moving right, left, up, down. You are stretching or shrinking your graph. If there's a number in front of your function, so if it said like 2x squared, okay, if that number without the positive negative sign, because we're going to ignore that, positive or negative tells you if there's a reflection. What we're looking at is the number that's attached to it. If that number is greater than 1, then there's a vertical stretch. And it makes something like a V or a parabola more narrow. And it would make a square root tall. So I'll show you the difference between all of these. If that number is in between 0 and 1, let's say it's 1/3 x squared. So we're talking a fraction that's not improper. Then there's a vertical shrink. It is wide, or in square root form, it is flat. Your points are 1/3 as high or 2 times as high if it was something like that. So parent function here is a what? Its absolute value, which looks like a V, okay? The 3 in the front is telling you that this is a stretch, a vertical stretch, or it is a more narrow V, okay? You can use either term. I don't care which one, as long as you know what it means. So my point is at 0, 0. If my normal absolute value looks like this, then I just need to make this more narrow than that, okay? Because you won't draw both, you'll just give it to me like the end here, unless it says to draw both. Your job is to make sure that I know that that was supposed to be narrow. So you will literally write next to it narrow, or you will write next to it stretched, because your stretched is going to be different. I mean, your normal is going to be different from somebody else's. So the way I know what you intended is literally that. You will write the word narrow, or you will write the word stretched. And then the 1/2 is making it shrink or wide. So you'll do it just like that. Because things like square roots and cubic, they can't really get narrower. They get taller or wider. So if that said 3 square root of x, then instead of it being your normal arc, it's a taller arc, something like that. It's 3 times as high. And if it said 1/3 square root x, then it'd be flatter than normal. So if this is your normal, then it's flatter. So sometimes narrow and wide get confusing when you get into something like a square root. Questions on that? All right, so we're going to put it all together. This says identify the parent function, describe the sequence of transformations from f to g, sketch the graph of g by hand, and then use function notation to write g in terms of the parent function f. What is my parent function? X squared. So f of x equals x squared is my parent function. What changes took place from x squared to this? So what's the 3 at the front doing? It's an up. It's a vertical shift up 3 places. What's the 2 on the front of the parentheses doing? Narrow or stretched. What's the -4 underneath doing? Right 4. So I go right 4, up 3, plot my point, make it a narrow parabola. So this is fine for this. Like when you're describing notation to me, that's fine. Up 3, narrow, and right 4 is fine. Notation just like that, okay? And then we're going to sketch it by hand. And then D says use function notation to write g in terms of the parent function f. So basically, we want to replace the squared with this because I already identified that x is squared. What I need to happen is I need that this x minus 4 gets plugged in there so that x minus 4 is squared. But instead of writing the square, I write it as f of x minus 4. So that's already saying take f of x, which is x squared, and plug x minus 4 into it. So I'm here already. If I was to actually like work it out. Then to that, I need to multiply it by 2 and add the 3. You can either add the 3 at the front or the back, it doesn't matter. So basically, whatever's inside your function, your absolute value, your square root, whatever that is going to get plugged into your f. So that's going to be like your f of whatever. And then all the other shifts, the reflections, are going to happen outside that graph. So if it had said -2, then I would have just written -2. The only thing that needs to get plugged into where your f of x goes is whatever's inside the parentheses or inside the absolute value or inside the square root. So you're writing like g of x in terms of f of x. So on your homework, you're going to get questions that are graphed by hand. Go ahead and do it. Don't use the platform if it's frustrating, if it's glitchy. I'd rather you draw it in Notability anyways because you're going to have to draw it by hand on your test. There's multiple choice so that you can look at that multiple choice. And then there's also ones where you have to take something where it gives you the graph and you have to give it the equation. So I know that this is a parabola, which means it's squared. I know it's shifted 4 places to the right, 3 places up, which affects what's inside my parentheses and outside. And then build your function from there.